Algebra 2. In this video, we're going to start section 7.2, angles. And today we're going to be focusing on standard position of an angle, as well as going from degrees to radians. So let's first talk about what standard position is. Alright, so standard position of an angle, let's make a coordinate plane to graph our angle on. Go up to 4, I think. So 4, 3, 2, 1. You are going to want a straight edge. Okay, so first of all, the vertex of your angle is at the origin. So let's write that down. So the vertex of your angle so that's going to be right here. And that's where it's always going to be for standard position. Your initial side is the positive x-axis. So for my angle, the initial side is where it's opening from, so that's going to be right here. Okay. Where your angle opens up to is the terminal side. So the terminal side is the other ray that forms an angle. So let's say we want our angle to open up to here. Okay, this side is the terminal side. Okay, now this isn't accurate yet because there is an infinite amount of angles. So positive angles open counterclockwise. So clock time goes this way, right? So counterclockwise. And what we do to note that positive angle is we start on the initial side and then we stop on the terminal side. So this is a 115-degree angle. We don't have a protractor, so it might be a little off, but that's okay. Whereas negative angles open clockwise. So if I started on the initial side and went to the terminal side in the other direction, okay, that would be negative 245 degrees. Now, a couple of degrees that you need to make sure you know is that this right here is 0 degrees, and then a quarter of the way up is 90 degrees. all the way to the other side is 180 degrees. 3/4 is 270 degrees. And then a full circle is 360 degrees. Now you can go around more than once, or you could go backwards more than once. And depending on your angle, you'll do more of a loop. So we can do a quick example. And let's sketch an angle. In standard position. So maybe I say 195 degrees. So what you're going to do is you're going to make a coordinate plane first. It doesn't have to be as big as the other ones we did. And then you need to keep in mind what each part of the axis is. So if we're doing 195 degrees, and this is 180 degrees, and this is 270 degrees, then we're going to be opening up somewhere over here. And that's why we're saying sketch. We don't have protractors. It doesn't have to be 100% accurate. But you do need to be relatively in the right area. So let's put our ray with an arrow from the origin out, and then we need to label our angle with an arrow saying it opens from here and ends on the terminal side, and label the angle as 195 degrees. Now, like I said, you could go around more than once. So if I said 765 degrees, you could think of it as, okay, well, where would that look inside my 360, right? So we could take 765 and subtract 360, that's 405. Subtract 360, and that's 45. So that means that this is going to be in the same vicinity as a 45-degree angle. So that's just going to help us figure out where exactly to put it if you're having a hard time visualizing. You can figure out where would it be in terms of 0 to 360. So the angle is going to be right in between 0 and 90. But because I had to go around more than once, right? Going from here, right? So this is 360 degrees. And then we go around another time. And then we have to go a little bit more. Okay, so that's how you could draw an angle bigger. Alright, now, radians is going to be another thing that we're going to be working with in this chapter. So, radians So radian measure, what is a radian? Radian is the length of an arc. And here are some common angles that you need to know. Okay, so 30 degrees is equal to pi over 6. 45 degrees is equal to pi over 4. 60 degrees is equal to pi over 3. 90 degrees is equal to pi over 2. 180 degrees is equal to pi. 270 degrees is equal to 3 pi over 2. And 360 degrees is equal to 2 pi. We'll also be doing some conversions in this chapter. Oops. And the conversion factor for degrees to radians is equal to pi over 180 degrees. Okay, so if I drew a coordinate plane before that you really, I mean you have to know all these, but I would start with knowing the axis. So here we have 0 pi. Here we have pi over 2, going all the way around. It's pi, 3/4 is 3 pi over 2. And then all the way around the circle would be 2 pi. Okay, and let's just do one example of standard position in radians. Now, you have to be careful because your instinct is going to be to convert it to degrees, and we do not want you to do that. We want you to keep it in radians and get used to radians. So let's do sketch the angle in standard position. So let's have the angle be 2 pi over 3. Okay, so first start by making your coordinate plane. And I also think, especially when starting out with radians, it's helpful to label those 4 parts. So remember, this is 0 pi, this is pi over 2, this is pi, 3 pi over 2, and 2 pi. Okay? Now, where the heck is 2 pi over 3 going to go? There's a couple ways you can think about this. One tip that I like to teach is if you can rewrite this, right? Rewrite it in terms of the denominator. So pi, we could also think about it as 3 pi over 3, right? And that's kind of helpful because 2 pi over 3 is going to be right before that. You could also try to break it up in 2/3, but 2 pi over 3 is going to be somewhere in here. So I'm going to draw my arrow in the direction and label it 2 pi over 3. And that is sketching in standard position for radians and degrees. And in class, we'll focus more on this as well as conversions.